Okay, so now we're going to go over symmetry elements that are reflections. And so reflections, there's three different types of reflections, and they're given by the Greek letter sigma. The first is a horizontal reflection given by sigma h. And that is a mirror plane, essentially, okay, that is perpendicular or horizontal to the principal rotation axis of the molecule, okay? So an example would be benzene. Benzene, the principal rotation axis is a C6. You can rotate this molecule 60 degrees and get back the same molecule. That's the highest order rotation axis, okay? There are other rotational axes in this molecule. For example, there's a C2 going right through here. That would be spinning the benzene molecule like this, okay? But that's a C2, not as high of an order as C6. So it's not, so the principal one is a C6. So we define this as our Z-axis. And a horizontal mirror plane is one that is perpendicular to that Z-axis. So it's going through the X and the Y plane. And so just to visualize, right, a mirror plane here, again, here is cyclobutane. And so you kind of see the side view. Your C4 is your principal rotation axis. That's going there. You can see that it's perpendicular. The plane is. And then we can play the animation. Okay, and basically you can see the things. The hydrogens are moving and switching locations from top to bottom and bottom to top. And the carbons are staying still because they're in the plane, right? And I mentioned that there are those other rotational axes. So one of those is a C2. That's not a principal rotation axis. That's in a different position. So you can see these C2s there. And if you play one of those, right, that's going to flip the molecule in a different direction. And so, yes, that's a rotational axis, but it's not the principal one. It's not the highest order one, which is C4. And so your horizontal mirror plane is defined by it being perpendicular to the C4, the highest order. Okay, so let's go over now some other types of mirror planes that you can have. The next one is called a vertical mirror plane or vertical reflection, sigma V. This is just a mirror plane that contains the principal rotation axis. So it contains that C6 in benzene, and it's just like any other mirror plane though. And so for cyclobutane, there's two of those. You can see again the C4, that's the principal rotation axis, and these mirror planes are contained in it. Let's play one of these. So let me just uncheck one of these. So that mirror plane right there, that's a vertical mirror plane. It contains a C4. If we play that, you can see that everything in the plane doesn't move, but the things on the left of the plane went to the right of the plane, just like looking in a mirror, right? All right, so that's vertical reflection. Lastly, there is what's called a diagonal reflection. Diagonal and vertical reflections are very similar, but they are mathematically different, which is why we have to distinguish between them. So we give this a sigma D. It also, some people call them dihedral reflections. I call them diagonal. It's easier for me to remember it this way. Okay, and the rigorous definition, okay, and this will make more sense as we start doing problems in later chapters. But the rigorous definition is that just like a vertical mirror plane, it contains the principal rotation axis. How is it different? Rigorously, it's different because it also bisects the angle created by two C2 axes perpendicular to it, okay? Now, most of the time, I'd say 99% of the time, if you have a sigma V and a sigma D, okay, they both exist if they both exist in a molecule, the sigma D is going to be the planes that don't bisect the atoms. So that's the easiest way. So let's again look at, here's a sigma V, okay? Now let's add a sigma D in here. And so that's a sigma D, this sort of lighter yellow color, versus the orange is a sigma V. Look at the sigma V, it goes through the atoms. The sigma D does not. It goes through the bonds, okay? So D goes through bonds, dihedral or diagonal sigma Ds go through bonds. You can see there's 2 of them here. And those are all 4 of the sigma Vs and sigma Ds. But let's get to that rigorous definition and just try to explain that. We said that it's something, a mirror plane that contains a principal rotational axis, check, it does, right, C4, but it also bisects the angle of 2 C2s that are perpendicular to it. So the C2s in this molecule, cyclobutane, are right there. And so what you can see is that there's the 2 C2s, and the dihedral bisects it. It goes right through it. The verticals, okay, the verticals actually contain the perpendicular C2s. So that's the difference between these. And you will have to learn how to distinguish these, okay? So it takes some practice. You're gonna have to identify principal rotational axis, right? Is it an H or is it a D or a V? And then if it contains a principal rotational axis, it's a D or a V. And so then you're gonna have to look at the C2s, strictly speaking, or most of the time, like I said, 99% of the time, just look if it goes through bonds or goes through atoms. If it goes through atoms, it's a vertical mirror plane. If it goes through bonds, it's a diagonal. It's kind of diagonal through between the atoms in that way.